Here we have another simple problem. We have a container containing 1 kg of water at 0 degrees Celsius. There is a steel rod joining this chamber to a steam chamber having steam at 100 degrees Celsius. Now the area of cross section of the steel rod and the length of the steel rod is given. We have also been given the specific heat of water that to be 4180 joule per kg degrees Celsius. We can assume that there is no loss of heat to surroundings and this container does not absorb any heat. We need to find out the time taken for the temperature of water to rise to 50 degrees Celsius from 0 degrees Celsius. So the first thing you need to find out is what is the heat current across this steel rod. So for that, let us first find out the heat current. This can be written to be heat current in this direction will be equal to temperature over here minus temperature upon here upon the thermal resistance of the rod, that is equal to 100 minus 0 upon initial heat current was different. Let the heat current at time t. Now we have to integrate in this question because we see that the temperature at this end is keeping on changing. Let the temperature of water at time t be equal to capital T. Now the heat current at any time t can be written to be equal to 100 minus T upon R, where R is the thermal resistance of the rod. Now the thermal resistance of the rod can be written to be equal to X upon Ka. Now since the X is fixed, that is the length which is along the direction of the current, this area of cross section is also constant, therefore we can directly calculate R. This comes out to be equal to 10 into 10 upon K, the thermal conductivity. The thermal conductivity of the steel rod is 46 W upon Mk, forgot to mention it, K steel is equal to this much. We go 10 upon 46 into the area of cross section which is coming perpendicular to the current, which is equal to 10 centimeter square, that is 10 into 10 raised to minus 4 is equal to 10 raised to 4 upon 46. So we know the value of R. Let us solve the question now. This is the heat current. So when the temperature is T, it rises from T plus dt due to this heat current. This heat current multiplied by a small time interval dt will give you the heat supplied in dt time. This is equal to mass of water into specific heat of water into small change in temperature of the water. Now the value of I is known, so we write 100 minus T upon R into dt. This is equal to mass of water into specific heat of water into small change in temperature. Now this can be written as 1 upon Rms into dt is equal to dt upon 100 minus T. This is small dt, this is capital dt. We integrate both of these. The temperature rises from 0 degrees Celsius to 50 degrees Celsius and the time taken is 0 to T. Therefore we can write T upon Rms is equal to ln of 1 upon 100 minus T, and the limits are 0 to 50. On solving this we get T upon Rms is equal to ln of 1 upon 50 minus ln of 1 upon 100. This is equal to ln of 1 upon 50 divided by 1 upon 100, that is equal to ln of 2. Therefore we get the time as R into M into S into ln 2. So we have got the actual answer, we just need to feed in the values now. T is equal to Rms into ln 2, the value of mass of water is 1 kg, specific heat of water is given to be 4180 into ln of 2. Now the value of R was 10 raised to 4 upon 46, therefore multiply this by 4180 ln 2 to get our final answer as 6.27 into 10 raised to 5 seconds. So final answer for the time taken for the temperature of water to rise to 50 degrees Celsius comes out to be 6.27 into 10 raised to 5 seconds. The thing which you should have noted down in the important thing which you should have noted down in this question is that we have to integrate, because the temperature at this end is keeping on changing, so that heat current is not constant. Therefore, we integrate to find out the change in temperature corresponding to the heat current. So final answer is 6.27 into 10 raised to 5 seconds.